at the bottom of page 239, where it says think further, it asks, when is the inverse of a function also a function? And the answer to that is, you can write this in that space, when the original function passes the horizontal line test. So the example that we just did, can you see that the original function was a parabola? If we drew a horizontal line, we would hit 2 points. We would say that that parabola does not pass the horizontal line test because it hits more than 1 point. And when you switch x and y, horizontal lines become vertical lines. So your inverse won't pass the vertical line test if the original one doesn't pass a horizontal line test. So any parabola will not pass the horizontal line test. But something like an x cubed graph, remember that from our, what is it, our pink sheet? It passes the vertical line test and it passes the horizontal line test. So its inverse will also be a function. In higher level mathematics, we call these graphs that pass both the vertical line test and the horizontal line test one-to-one functions. That every x value has one y value, every y value has one x value. There's a one-to-one relationship. There's never a 1-to-2. That, like a parabola, there's a y value of 4 that could be from 2 squared or from negative 2 squared. So we would say that one isn't a one-to-one function. It doesn't pass the horizontal line test. And so its inverse is not a function. So then the next thing our unit does to complicate, this is like one of the most complicated questions in this unit because it requires you to do 6 things to answer this question. We're actually going to, if time works out great in this question, we're going to do this one. We're going to finish example 4, and then I'm going to come back and do another example like this one so you see more than one. So that's the hard part in math. I think sometimes a student needs to see a question like 6 or 7 times before you're confident on a test to do it. We have time usually only to do each question once in class. Then if you do the homework, you get to see it maybe 2 more times, so you're 3 times. Take home quiz, you get to see it another couple times on the review. So hopefully you've done a question 7 times before you get to your test. Usually if you've only done it once, chances are you're going to be making mistakes the first couple times you try it on your own. So this one is difficult, it's tough, because it asks you to do 6 things. Really, it's 3 things twice, so that makes it a little bit easier. But currently, we have a parabola. This parabola does not pass the horizontal line test. So the first thing they want you to do is they say, determine 2 ways to restrict the domain so that its inverse is a function. In other words, they're saying, and you don't do this on yours because I don't think you have an eraser, but could I erase some of the graph so it passes the horizontal line test? And with a parabola, can you see if I erase half of it? Now it passes the horizontal line test. I could either erase the 1 half or the other half. So as far as restricting the domain, the first way that we could restrict the domain is just say, oh, if I just take the x values bigger than or equal to 1, I would have that half of the graph, and that half of the graph passes the horizontal line test. I'm going to split my page in half here, and 2, I'm going to restrict the domain in a second way. And this time I'm going to say, well, I could have erased this half, but I could have also erased this half. Now the key thing in erasing half of the graph will be the vertex. And the vertex right here is at 1, 3. So because the x coordinate of my vertex is 1, that's how I'm going to restrict the domain. If my vertex was at a different spot, I would look at the x coordinate at that spot, because that's where it splits it into half. One half or the other half. Now, the nice thing about this unit is these are hard questions. We will only do them with parabolas. And you're always going to split that parabola up with its vertex, either this half or this half. So in some ways that makes it a little bit better. So now on my parabola, my original parabola, I have 1, 3. If I label some other points, I hope you can see that you've got 3, 7, and negative 1, 7. Those would be other points that you would have on your graph. If I drew the inverse, I could just switch my x and y coordinates. I'm going to draw my inverse in blue. Instead of 1, 3, can you see that you would have 3, 1? Instead of negative 1, 7, I would have 7, negative 1. And instead of 3, 7, I would have 7, 3. And so my parabola has been turned sideways. That's the entire inverse. If I wanted to graphically show the restricted domain part, and on your quizzes and tests, I will give you 2 separate graphs for these so that you can easily split it up. When x is bigger than 1, as far as my red graph goes, my red graph on the original, I have the point 1, 3, and 3, 7. And I would just have this half of the parabola. On my inverse, I would have 3, 1. And then which half of my inverse would I have? Well, if I had 3, 7, does it make sense that I would have the top part, which has 7, 3? So if I restrict the domain with x bigger than or equal to 1, I have half the parabola, and then when I draw the inverse, I just have a single square root equation. For the other one, I would also have still my vertex at 1, 3, but on this one I would have negative 1, 7. This would be this half of my parabola. When I switch the x and the y coordinates, I have 3, 1 again, but now I'm going to have 7, negative 1, and I'll have this square root graph. So determine 2 ways to restrict the domain. Those are 2 things we had to solve for. We haven't found the equations yet, but we did use a graph to illustrate each one. So I did the graph part before I found the equation part. So this is graphically the restriction and the new limit. What are we left to do? We need to find the equation of the blue part of the graph for both of them. Algebraically, how do we find an equation? We switch x and y and solve for y. So if I switch the x and the y coordinates, I would start with this. Now I'm going to get the squared part by itself by subtracting 3 on both sides. and then I can square root both sides. Finally, if I want to get the y by itself, I'd have to add 1 to both sides. Now, when we find the inverse of a parabola, we always get that plus or minus. The plus part will be for one of these, the minus part will be for the other one. And the reason I did the graphs first is because the graphs are going to tell you which one is the plus one, which one is the minus one. Remember, the negative outside the function would be a vertical reflection. If you took a square root graph and you did a vertical reflection, can you see that it would be going down instead of increasing and going up? So if we look at our blue graphs here, I hope you can see that this one is the positive one. And this one is the negative one. Because the second one, you had a square root that had a vertical reflection, now it's pointing down. So you can see which one has to be positive and which one has to be negative from the graph. So this question is difficult because it's asking you for 6 things. Really, 3 things twice. Restrict the domain, once here, once here. That's 2 things. Show it graphically, once here, once here. Another 2 things. Find its equation, once here, once here. So on your quizzes, I'll give you 2 graphs so that you can split your page and do it separately and find each of those things for each part. When you're finding the restricted domain, you are looking at your original graph, you're trying to find the vertex, and you will always cut it in half. So in this case, my x-coordinate of my vertex was 1, so I took bigger than 1 and less than 1. Okay? If your vertex is at a different place, that's going to change your restriction. If your vertex was at 7, 8, your x-coordinate is 7, then you would do x is bigger than or equal to 7, and x is less than or equal to 7. Okay, questions for this one are 10 and 12.